What's going on, everybody? Welcome back to the channel. If you're looking for the simplest way to solve questions like this, then this video is for you. Watch this, because when you see this method, you're not going to be seeing bases 2 and 8 the same way again. Now we have base 2, which is 2 raised to the power of 9 raised to power x all over. Now on the denominator we have 8. 8 can also be written as 2 to the power of 3. And it has a power of 3 to the power of x. Good. And this is equal to 1 all over 4. Now notice that the bases on the numerator and on the denominators are the same. So we're going to be applying the law of indices that says when I have, for example, a to power m all over a to power n, bases are the same. This is same as writing a to the power of m minus n. So that means this expression, take one of the common base, which is 2, then subtract the powers. So we have 9 to the power of x minus the denominator, the power is 3, times 3 to the power of x. And this is equal to 1 all over 4 is written as 1 all over, since 4 is same as 2 squared. Very good. So this becomes 2 to the power of 9 to the power of x minus 3 times 3 to the power of x equal to, now I'm going to be applying the law of indices here that says that when I have 1 all over a to the power of n, this can be written as a to the power of negative n. So let's express this like this. So this becomes 2 to the power of negative 2. Good. Now we see that the bases on the left and on the right are the same, so we can equate the powers. The power on the left is 9 to the power of x minus 3 times 3 to the power of x. This is equal to the power on the right, which is minus 2. And then simplifying further, 9 is same as 3 squared, and this is raised to the power of x minus 3 times 3 to the power of x, and this is equal to negative 2. Very good. Now this expression can also be written as 3 to the power of x or raised to power 2 by switching their positions, minus 3 times 3 to power x. Now I'll move negative 2 to the right hand side so that it becomes plus 2, and this is equal to 0. Very good. Now we see that we have 3 to power x here, and we also have it here. So we can introduce substitution. So we can see that let 3 to power x be equal to y. So that means this becomes y squared minus 3y plus 2 equal to 0. So we have a nice quadratic equation. Now in this quadratic equation, we can actually factorize. The factors of plus 2, we can use negative 1 and negative 2. Their multiplication gives plus 2. Their addition gives negative 3. So this factors into y minus 1 times y minus 2. Good. And this is equal to 0. So we have two cases. We have y minus 1 to be 0, or we have y minus 2 to be equal to 0. For the first case, which is this, I can move negative 1 to the right hand side so that I have the value of y to be 1. Or for the second case, we also move negative 2 to the right hand side so that I have the value of y to be equal to 2. Very good. Now let's substitute back these values of y here. Recall that 3 to the x is equal to y. So let's start with when y is equal to 1. So this becomes 3 to the power of x equal to y, which is 1. So this simplifies into 3 to the power of x equal to, now 1 can also be written as 3 to the power of 0. Well, we did that so that the bases on the left and on the right can be the same. And since we've achieved that, that means we can equate the powers. So x is equal to 0. So we've got one value for x. Now let's get the other value for x. When y this time is equal to 2. And let's substitute that here. So we have 3 to the power of x to be equal to 2, which is the value for y. But there is no way we can make the bases to be the same both on the left and on the right. So we introduce logarithm. Now, since I have the base on the left to be 3, I'll take the log base 3 of both sides. So we have log base 3 of the left hand side, which is 3 to the power of x, equal to, I'll also take log base 3 of the right hand side, which is 2. Now, since the base here and the base here are the same for the law of logarithm says we take the power, which is x, and this is equal to log 2 base 3. So we have two values for x equal to 0 and x equal to log 2 base 3. Now let's check our solution. The first is when x, the value of x, we got to be 0. Let's put it down here to see if we're going to be having 1 all over 4 as the result. So we have 2 to the power of 9 to the power of 0 all over. We have 8 to the power of 3 to the power of 0. So we're checking if we're going to be having 1 all over 4. So this gives 2 to the power of 9 to the power of 0 is 1. So this is 2 to the power of 1 all over. Now the denominator, we have 3 to the power of 0, which is also 1. So this gives 8 to the power of 1. So we're checking if we're going to be having 1 all over 4. So 2 to the power 1 is 2. 8 to the power 1 is 8. So we can break this down. 2 divided here is 1. 2 divided here is 4. So we have 1 over 4 on the left, which is equal to the right hand side. So our value for x equal to 0 is correct. Now let's check for when x is equal to log 2 base 3. Now we'll plug that here. So we have 2 to the power of 9 to the power of log 2 base 3 all over. We do that to the denominator as well. 8 to the power of 3 to the power of log 2 base 3. So we're checking if we're going to be having 1 all over 4 as the result. Now looking at the numerator, this is 9 as a base here. We want to make this base to be the same as 9. And in order to do that, we can raise 3 to the power of 2 to get 9. So 3 to the power 2. And as I raise this 3 to the power 2, I must do the same to this number here. 2 to the power 2. Very good. So this results into 2 to the power of 9 to the power of log. 2 squared is 4 and 3 squared is 9. Good. All over. Now the denominator, we have 8 to the power of 3 to the power of log 2 base 3. So we're checking if we have 1 all over 4 as the result. Now, there is a law of logarithm that says that when I have, for example, b to the power of log a base b, as long as this base and this base here are the same, the result will always be this number a. So now, looking at what we have here, the base here and the base here are the same, so the result will be 4. So we have 2 to the power of 4. So 2 to the power of 4 all over. Now, the denominator, the base here and the base here are the same, so we take the number. So this becomes 8 to the power of 2. So we're checking if we're going to be having 1 all over 4 as the result. And then simplifying further, 2 to the power 4 is 16 all over. 8 squared is 64. So will I be having 1 all over 4? Sorry for that. Now look at 16 here is 1. 16 into 64 is 4. So we actually have 1 all over 4 equal to the right hand side 1 all over 4. So both answers we've got for x equal to 0 and x equal to log 2 base 3 are actually correct. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.